Hi, my name is Parvat Sapkota. I'm a senior majoring in physics and economics at UTA. Today I'll be talking about the research that I have done on the Dr. Ch's lab, and the title of my research is Development of the Web-Based Simulation Platform for G-microMC. We know that the radiation affects the DNA, but how does it actually do so? It primarily affects in two ways, direct and indirect. In the direct method, the radiation consisting of charged or uncharged particles directly interact with the DNA. In the indirect method, however, the radiation instead react with other mediums in order to produce free radicals. These free radicals then go on to interact and thus affect the DNA. So what has been done till now? Monte Carlo simulation has been pretty successful in order to simulate this process. It has been able to simulate the physical, physicochemical, and the chemical process, which are the steps of the indirect process. This process also incorporates the direct process as well. It also has been able to quantify the DNA damage. But what is the problem with it? The main problem lies in simulating the chemical states, because simulation of chemical states takes a long time. So where does the GMicroMC comes in? It is also a Monte Carlo simulation tool, but it utilizes the parallelization of the GPU in order to do the computation, and using it we are able to increase the computation speed not only in chemical but in physical and physicochemical process as well. In fact, using it we are able to reduce the simulation time for chemical states by around 540 as compared to using CPU. Now what is my work? My work focuses on the user experience side of things, as the user have come across different difficulties while using this program. First is the GPU, as users are having trouble setting up the appropriate environment in order to run the GMicroMC program itself. Second is visualizing the output, as the program do not consist of any mechanism to visualize the outputted files. Third is the setup environment, since although the user will be inputting required parameters, they will have no idea about how they have set up the environment. Thus my work is to solve these issues by developing the web-based simulation platform. Our methodology consists of developing two types of server, web server and application server. In the web server, we plan to accept user input, visualize user setup, kick off the simulation, and then visualize the result. In the application server, however, we only run the GMicroMC simulation based on user input. For this, we plan to use Django, 3.js, and Part.js framework, and the communication between two servers will be established via reverse proxy. In our result, we were able to develop the first version of the GMicroMC platform. This figure shows how the user can easily visualize the environment that they have set up. Here, they will input the parameters and they will visualize the environment over here. This figure shows the visualization of the physical states. Here, the figure shows distribution of energy deposition events. This figure shows the visualization of the physicochemical states. Here, the figure shows distribution of radicals after water radiolysis. These three figures show the visualization of the chemical states. Here the first graph shows change in counts of different radicals per 100 eV of deposited energy as the time progresses. Second is the visualization of all radical distribution at a certain time. Third also shows similar visualization, but here we consider only one particle, which is hydrogen peroxide. For our own purposes, we then looked further at the chemical states. Here we looked at radical distribution at different time periods. Here the top figure shows distribution of all radicals, while the bottom figure shows only distribution of one radical. The first figure is at 10 picosecond, second is around 3000 picosecond, and the third is around 1 million picosecond. Looking at above figures, we can see the division of particles, and looking at the below figures, we can see the increment in the number of particles as the time progresses, which is what we expect in the chemical stage. So to conclude, we were able to establish the first version of the simulation platform. One important thing to note is that all this process is currently taking place via communication between local machine and the application server, and not between web server and application server. So accordingly, in our future work, we plan to deploy remaining code to the web server, complete setting of the connection between the web server and the application server, and to use the platform for educational purposes. And that will be all. Thank you so much for listening. Would you like to learn more?